All the ingredients are now in place for the final effect, that of particles tearing away from the text object. Make sure the particle view window is displayed. You can use the 6 hotkey to that effect. Also, from this moment forward, there is a chance that real-time feedback in the viewport can become a problem. You can help with viewport performance in a couple of ways. First, you can set the rendering mode to shaded. You don't need lighting effects and shadows at this point. Second, you can hide the text clean object. You don't really need it for particle behavior. If you followed the last movie, you have already added a collision operator to the existing event. You have even created an animated physical deflector in the scene to use for that purpose. However, you have not yet defined it as a collision deflector to affect the behavior of the particles. Make sure the collision operator is selected and add the animated deflector as a collision object. As the deflector moves from left to right, the particles bounce off it and start to move in that same direction. Next, you'll fine-tune that behavior in a separate event. The main reason why you're better off using a separate event is that unlike the existing invisible particles clinging to the text, the new animated particles have to have a shape that you can render. Drag a new shape operator to an empty area of the particle view window. This creates a new event. Make sure its display operator is set to a different color than the one in the previous event. This will make it easier to differentiate the two events. Wire the collision operator to the new event. You're essentially saying that once a particle bounces off the deflector, it searches the new event for behavioral properties. At this time, the ticks are of a different color in the viewport. At render time, though, they are displayed as 3D cubes as stated in the shape operator. You'll get to change that in a moment. First, add a speed operator below the shape operator. By default, the speed operator sends the particles in the direction of the pflow icon's arrow, in this case downward. This can be better seen in wireframe mode. Obviously, you need the particles to move to the right and perhaps even slightly up. Rotate the pflow icon accordingly. A wire rotation value of -95 should do the trick. You'll need to adjust the speed parameters a bit. Decrease the speed to about 150 with a 50 variation so that all particles are not traveling at the same speed. Try a divergence value of about 25 to open up the flow in a cone-like behavior. As always, these are values you can experiment with and not cast in stone. Next, you will deal with options such as rotate and scale. In order to get a sense for orientation and scale, however, you need to be able to see the particles. Select the display operator in the new event and set it to geometry. Go back to the shape operator and set the cube size to 5. You can also change the shape altogether. In this movie, we're using a 2D square shape. Add a rotation operator so that all particles are not oriented the same way. You can even add a spin operator. Leave the spin rate at 360 but add a bit of variation to it. To ensure the particles are not of the same size, add a scale operator. Leave the proportion constrained and use a 50% variation. You're almost done. All you need now is to map the particles and apply the rusty material to them. Add a mapping object operator. Use the Add tool to select the rusty text in the viewport. This operator ensures each particle is mapped the same way as the area where it originates. Make sure to disable the Uniform Color per Particle option. Otherwise, each particle will have a uniform color as opposed to a rust pattern. Add a material static operator. This is used when you need to apply a non-animated material to the particle system. You may notice at this time that the system is taking a bit longer to refresh. Hide the text object to help a little more with viewport performance. Use the Slate Material Editor to instance the rust material into the operator. Test render the scene. Notice that the material is not visible at render time. Mapping and materials need a refresh when added to a particle event. Simply disable and re-enable the mapping and material static operators. Test render the scene again. This time, the particles are displaying the rusty material. Keep on fine-tuning the scene. Try a larger number of particles, such as 3000. Remember, though, that the more particles you have, the harder it is for real-time performance and for rendering. You can also try a different particle shape. It doesn't have to be a square. When you're ready, unhide the text and render your scene. A final animation is also provided for your convenience. In this tutorial, you have learned to use a particle system to simulate the effect of tearing off a layer of rust from a text object. In the process, you learn to use the slice modifier to make one object disappear while another one appears. As always, we hope you have found these techniques useful and that you will be able to use them in your work.